Hi guys, welcome to another video by Darklink Does Math. The content in this video is geared towards 6th grade math standards. These videos are public so that my students may access this information easily, as well as anyone else looking for math help. I hope you find this video helpful. If you do not, I hope you can find what you're looking for elsewhere. There's a lot of information out there. Be aware that I'm not perfect, so there may be the occasional mistake. I apologize in advance if this should happen. So today we're going over 12.2 dot plots, specifically how to make a dot plot, and a few different ways on how to interpret them or gather information about them. So we've got 4 vocab terms. First one, dot plot. Dot plot is a data display that shows the frequency of data on a number line. It uses a dot like that to represent each time something happens. So a data display that shows how often something is occurring on a number line. It uses dots to represent each time something happens. So your dot plots can have different shapes, and these shapes are called skewed or symmetrical. There's left skewed, right skewed, symmetrical, and nearly symmetrical. And we'll go over those later. Now, what do these terms mean? It means, well, the first one, skewed, a data set in which the mean, median, and mode are not all the same. So the mean, median, and mode are not all the same. Now, real quick, what is the mean? That's your typical average, where you add up all the numbers and divide by how many there are. Median, which is the middle number, as long as all your values are listed from order of least to greatest. And mode, that's the number that happens the most. So if these 3 values are not all the same, your data is skewed. And we're going to go a little bit more over that later. Mean, median, and mode, we're actually going to discuss in lessons 13.1, 13.2, and 13.3. And you'll find those videos on my YouTube channel. Now, without having to calculate these 3 values, how are you going to determine if your dot plot is skewed? Well, I'm going to show you a way to look at the amount of data values and its outline or shape to determine that. Now, the opposite of being skewed is symmetrical. This means you have a data set in which the mean, median, and mode are all the same. So you've got skewed or symmetrical. Skewed means mean, median, and mode are not going to be the same values. Symmetrical means all 3 will be the same values. We're not actually going to calculate the mean, median, and mode, but I'll show you how to determine this. Our last term, range, that's the difference which means subtract, between the greatest and least number in a data set. So the difference between the greatest and the least number in a data set. So to do this, you look at your greatest number, which is also called the maximum. That's your big number, or the biggest number. And you're going to subtract the minimum. Again, that would be your smallest number in your data set. So maximum minus minimum in that order. That simply just tells you how far your data is spread out. All right, first example. We're going to go over how to make a dot plot. So our scenario is the number of text messages sent by some students one day is as follows. We've got some values, 12, 11, 10, 15, 13, 15, 12, 11, 12, and 11. Now these are the number of text messages, and they span from 10, you'll see is our lowest number, to 15, which is our highest number. So 10 is our minimum, 15 is our maximum. Now to construct a dot plot, you're going to draw a horizontal number line that extends from your minimum to your maximum, so 10 to 15, and then you'll plot your data points. I'm going to give you 4 set steps to do this. So first step, they've already said that, draw a horizontal number line. So let's do this as we write the steps. So draw a horizontal number line. Next, title will go on the bottom. So make a title, put it on the bottom, and your title is what the data is about. So what is this data about? Well, it's about the number of text messages sent by students. So I'm going to write number of text messages. And I'm leaving room right here because we're going to put numbers right there, which is our third step. Our third step is to write numbers. Now, how do you know what numbers to put on there? It's going to go from your minimum to max. So it goes from your minimum number to maximum number. So 10 is our minimum number of text messages. 15 is our maximum number of text messages. So we're going to put or go from 10 to 15. So 10, 11, 12, 13, 14, and 15. Going to adjust the size of that. All right, now before I continue, we need to understand that this title tells us what these numbers mean. So this title tells us what the numbers mean. Now, what do I mean by that? Well, it's number of text messages sent. So that means this is 10 text messages, 11 text messages, 12 text messages, and so on. So these numbers go with this title. That's what they mean. So 15 text messages. All right, our fourth step and final. You're going to put dots on the line above each number every time it occurs. So every time something happens, you put a dot to show that it's happening. So we're going to look at our chart with all our values, our data set, and every time it happens, I put a dot. So I see 10. I'm going to place a dot. Do I have any more 10s? No. So what does this one dot mean? This dot means one student sent 10 text messages. So just read top down. So one student sent 10 text messages. Next, I have 11s. I have 3 of them. 1, 2, 3. So we're going to line up our dots. I'm not going to just spread them out wherever. So 1, 2, 3. Keep them consistent. So what does this mean? This means 3 students sent 11 text messages. Again, top down. Next, we have 1, 2, 3 12s. So again, line up your dots, keep them consistent. Notice, same level. This means 3 students sent 12 text messages. So 3 sent 12 text messages. Next one, 13. There's only one value. So that means one student sent 13 text messages. Next, 14. There are no 14. So no one sent 14 text messages. Now I have my last 2 values, 15 and 15. So 1, 2, again, keep your dots consistent. 2 students sent 15 text messages. So this is our dot plot right here. So title on the bottom, the numbers, the title tells you what those numbers are. Now those dots, again, what do they represent? The dots are the frequency. Oops. The dots are the frequency. Again, frequency from our previous lesson is how often something happens. So we can see that this happens once, this happens 3 times, 1 time, no time, 2 times. So the dots are the frequency, and they typically represent people or events. What do I mean by events? I mean by, you'll see that in the next example, but something happening. In this case, the dots represent people. So in our story, we see that these are the number of text messages sent by students. So each number represents a student sending that many text messages, that many texts, and so on. So these dots represent students. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 students. They're sending various amounts of text messages. All right, next example. June tossed a number cube. So this is an example of an event. June is doing something. She's tossing a number cube or a dice, and it's numbered 1 to 6, and she's doing it 20 times. So 20 events, 20 actions. She's recording the number that she sees in the table below. We're to represent the data on a dot plot. Now before we make our dot plot, a couple things about this chart. Charts typically follow patterns. The top is typically going to be very close to what your title should be. It's what it's about. And they also represent the numbers that are going to go on your line. So the top row is pretty much what it's about. So it's sometimes good for a title, and it's the numbers that are going to go on your line. it can get a little confusing because I see 1, 2, 3, 4, 5, 6, 2, 3, 6, 1, 5, 3. It's a lot of numbers. It can get a little jumbled up. The bottom row, frequency. This is how often whatever above it is happening. So 2 times the number 1 was rolled. 3 times the number 2 is rolled, and so forth. So frequency is going to be how many dots we draw. And again, it's how often it's happening. Frequency is how often does something happen. So number 1 is rolled 2 times. Number 6, again, number 6, it happens 3 times. All right, so first step, we draw our number line. Second step, we need a title. Now, it just says number. I'm not going to put number because I have lots of numbers. That can get a little confusing. So I'm going to be a little bit more specific and look at the story. It says, June tossed a number cube, numbered 1 to 6 20 times. So this number 1 through 6, that's the number that she's rolling on her cube. So I'm going to add a little bit more. And instead of just saying number, I'm going to say number rolled on a cube. That will specifically tell me what those numbers mean, which are, again, next step, we want to go from our minimum to our maximum. So 1 to 6 should go on the number line. So 1, 2, 3, 4, 5, and 6. And I overestimated a bit, so I'm going to shrink my number line a bit. All right. So this means 1 was rolled on a cube, 2 was rolled on a cube, 3 and 4 and 5 and 6 was rolled on a cube. The title tells you what the numbers mean. Okay, next, I need dots. So how many times was the number 1 rolled? The frequency is 2, so 2 times. So I'm going to put 2 dots above 1. It happened twice. Next, the number 2 was rolled 3 times. So once, twice, 3 times. Keep your dots consistent. The number 3 was rolled 6 times. So once, twice, 3 times, 4 times, 5 times, 6 times. Next, the number 4 was only rolled once. The number 5 was rolled 5 times. Nice coincidence. 2, 3, 4, 5. Again, keep your dots lined up. I mean, you wouldn't not want this stack to be taller than that one because this is 5. That happened 6 times over there. Okay, next and last. The number 6 was rolled 3 times. So once, twice, 3 times. Okay. We've constructed our dot plot. It has the title, the numbers, and how many times that thing happened. So these dots don't represent people. These dots represent an event. Every time the dice was rolled. Okay. Our next scenario, we're going to go over some shapes. Before I do that, let's discuss what those options are. There are 4 shapes of dot plots, or in general, any graph that you could find. The first is symmetrical. And according to our definition, that means your mean, median, and mode will all be the same. The second is nearly symmetrical. That means your mean, median, and mode will almost be the same value. Then you have left skewed, and then you have right skewed. So we're not actually going to calculate the mean, median, and mode. We're going to show you how to figure that shape out based on what your dot plot looks like and where the data values are. So we've got 3 examples. Are the shapes of these dot plots symmetrical or skewed? So we've got 3 different examples. The first one, your first step is going to be to find the mode. The mode is the thing that happens the most. So what happens the most on this? I can clearly see that 4 happens the most. I don't know what 4 represents, but it occurs the most. Maybe it's eating 4 cookies. So 4 people perhaps ate 4 cookies, and that's the most common thing that happened. Who knows? So anyways, this is our mode. It's the tallest stack. It's the thing that happened the most. Next, I'm going to count the values on the left and on the right. So on the left, I see 1, 2, 3, 4 data values. On the right, I see 1, 2, 3, 4 data values. I'm going to compare those. They're identical. So right now, this could be symmetrical because it's perfect on both sides. I am going to look at what it looks like, its outline. So I'm going to draw an outline around the dots to see what it looks like. And I see that it looks like a perfect symmetrical mountain. So the shape of this is symmetrical. What does that mean? That means if I calculated the mean, median, and mode of all of these data values, 1, 2, 3, 3, 4, 4, 4, 4, 5, 5, 6, and 7, I'm going to get the same answer for all 3. The next one, find our mode first. So the mode is the thing that happens the most. 6, whatever it is, happens the most. It's the tallest. So this is our mode. I'm going to calculate the number of data values on both sides. So on the left side, I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 data values. On the right side, I only see 1 data value. So obvious, it's imbalanced. That's kind of what skewed means. It means your data is not perfectly balanced. It's offset. So the idea is, where is all the data? Well, if I look at my outline and I look at these numbers, I'll see that all the data is shoved on the left side over here. So that means this is left skewed. All our data has been skewed to the left. It's been pushed over there. That's what that means. So if I were to calculate my mean, median, and mode, I'm going to get different values, probably really different values, because all of my information is pushed over on the left. So it's going to vary. Okay, one more example. Where's our mode? What happens the most? 3 happens the most. I don't know what 3 is or represents, but it happened the most. So that's our mode. Going to look at my outline as well. Oops. Going to count my values. So on the left, 1, 2 values. On the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So most of the data is pushed on the right. So this would be right skewed. So I have 3 different examples: symmetrical, left skewed, and right skewed. Which one was not covered? The nearly symmetrical. So we're going to have an example of that in a bit, but I'm going to draw a simple sketch as a preview. So let's say I had some values that looked like this. And I looked at my outline. Again, this is my mode. There are 3 on the left side. There are 3 on the right side. So I might say symmetrical, but if I look at my outline, it's not perfect like this, right? I could fold that in half and it's the same. I could fold that in half. It's not going to be quite the same. It's a little offset right there. So this is what nearly symmetrical would look like. One example, that is. So those are your shapes of your graphs. It means your mean, median, and mode are either going to be different or all identical if it's like this. Okay, we're going to look at a couple of examples and describe our data. So the money in dollars that 15 students earned by babysitting in 1 week is shown in the dot plot. Briefly describe the distribution of earnings of the student. So when you have a question that says briefly describe, it's looking for multiple things. Specifically, in general, 3 things. First, we're looking for the shape. Second, we're looking for the range of the data. How far is it spread out? And third, we're looking for a conclusion. A conclusion is essentially an observation that sticks out about your graph or your data. Okay, so the first one, the shape. So we're going to look for our mode, which is right here. 20 happens the most. Now, what is this? Again, your title tells you what the numbers mean. So this is your savings in dollars. So that means this is $17, $18, $20, $22, $23, $24. So these dots, in this case, represents people, students. So 1, 2, 3, 4 students saved $20. So that's what happened the most. That's our mode. Now, how many values are on the left side? 1, 2, 3, 4, 5, 6. How many are on the right side? 1, 2, 3, 4, 5. The numbers are really close together. Let's look at our outline real quick. It almost looks similar, and the numbers are close, so this shape would be nearly symmetrical. That means the mean, median, and mode will be close together if we calculated them, which we're not going to do until a future lesson. All right, second, range. I want to know how far the data is spread out. And remember, the range is your difference between your maximum and minimum number in that order. Got to show work on this one. So the range. First, we need our maximum. Our maximum is going to be this dot. This dot is $24. The lowest is going to be this dot, which is $17. Again, that's our minimum. So we're going to do maximum minus minimum. $24 minus $17. So $24 minus $17 equals, it's going to be 4, 5, 6, 7. 7 what? You have to have a label. $7 is your range. So from the highest paid person to the lowest paid people, there's a range of $7. Third, conclusion. So what sticks out the most? Typically, your conclusions are going to be about the mode. What is happening most often? Because that's really why we want to graph something. We want to see what sticks out. So what sticks out about this? Well, most students are saving $20 in 1 week, or earning $20. Let's see, actually it says earned. I don't know why they have savings, but whatever. We're going to go the same thing. So your conclusion is going to follow a typical pattern. Typically it's going to be most what did what. In this case, it's most students. What did most students do? They earned. And what did they earn? Well, most students earned $20. So again, in general, your conclusion is going to follow a pattern that goes most what did what. So in this, most students earned $20. We're going to have another example with that. Last one. The number of movies that 12 students saw last month is shown in the dot plot below. briefly describe the number of movies seen by the students. So again, it's got that phrase, briefly describe. So we're looking for three things: shape, how far the range is, like how far your numbers are spread out, and third, a conclusion. What can you tell me about it? What sticks out, in other words? All right, first, shape. Let's find our mode. So what happens the most? Again, 4 movies were seen. So that's what these numbers are. How many movies were seen? So one person saw 3 movies last month. 1, 2, 3, 4 students saw 4 movies last month. 1, 2, 3 students saw 5 movies last month, and so forth. So most students saw 4 movies last month. That's our mode. How many values are on the right? Sorry, left. I know my directions. On the left, 1. How many are on the right? 1, 2, 3, 4, 5, 6, 7. Let's look at the outline. So most of the data is on the right side. There's a big difference between 1 and 7. So that means it's right skewed. Most of the data has been pulled to the right because of these people watching lots of movies last month. So this is going to be right skewed. Our data has been skewed or pulled or pushed to the right. Next, the range. How far is it spread out? So our maximum is 8 movies seen. Our minimum is 1. Sorry, not 1. Don't get confused on your dots. There's 1 dot. So one person saw 3 movies. So our max is 8 movies. Our minimum is 3 movies. Make sure you look at the number. Make sure you look at your title. So maximum, which is 8, minus minimum, which is 3. We're going to get 5. 5 what? This is 5 movies. So the range of movies watched is 5, all the way from 8 down to 3. All right, last, conclusion. What sticks out? Again, it's going to be most, what, did, what. So most, these dots represent people, students, to be specific. So most students, what did most students do? They were seeing movies last month. So most students saw, what did they see? Most students saw 4 movies last month. All right, so that covers dot plots and various ways to interpret them and gather information about them. I hope this has helped. If it has not, I hope you can find what you're looking for elsewhere. Y'all have a great day.